Hi, my name is Ashley Tish, and for my science projects, I wanted to learn more about the phases of matter, liquids, solids, and gases. My dad is a scientist, so he brought me to his lab to learn more about the three phases of matter. My dad's name is Sean Tish, the scientist, and he's going to explain how the three phases of matter are different, how they change from one to another, and the effects of temperature and pressure. He will also use his high-tech scientific equipment to show us what they look like. Oh, here he is now.
Hello, my name is Sean Tish, and I'm going to tell you about the phases of matter. I'm happy to be here with you today because I have a big brain, and I know a lot about this stuff. Come over, let's talk about solids first. We need to get a good look at this chloroborohyphenate sulfonate.
What he's trying to say is we need to get a good look at this crystal.
Maybe something a little better. Still not good enough. My mega electrohydrosuperscope should do the job. As you can see, the ionic interactions within the crystalline structure causes...
What he's trying to say is inside the crystal you can see the atoms in an organized state, which is called a solid. You can see that they're not moving around as much as a liquid or a gas. They stick together like they're cold or they're attracted to each other.
Still not good enough. What we really need is my ultra mega honkin' electromagnetic grapher scope.
What?
I'm pretty sure this'll do the job. Let's put it on the crystal on the scope. This demonstrates the harmonic vibratory action of
To
those.
say this in a simpler way, in a solid, even though the atoms vibrate, they are so strongly attracted to each other, they stay in one place.
How about we take a close look at some dihydrogen monoxide?
You mean water?
Here you can see
what he was going to say. In a liquid, the atoms move freely, but are still close together as if they are attracted to one another.
To learn more about gases, let's go over to my gas analyzation chamber. In the gas chamber, you can see the increased kinetic motion.
I'll take it from here. Particles in a gas move around freely just like a liquid, but they don't stick together at all. So they bounce around like a party crew or a bunch of little kids. This is a good place to see what happens when you heat atoms up because it's easy to see in gas.
I'll have my assistant turn the temperature up on the gas analyzer. Whoa!
Now that the temperature has increased, the molecules and the gas are moving much faster.
What was that? Rewind the footage. There must have been some kind of quantum space-time anomaly.
Translation for 7th graders? That was weird. We can demonstrate heating up a solid by putting this ice in the water. If we heat up a solid, the same thing happens. The atoms, which are tightly attracted to each other, start to vibrate faster. When they are vibrating fast enough, they break apart and start to move. That's the phrase transition from solid to liquid, or melting.
The ideal gas law, PV equals nRT.
Dad, I've got this one. This calls for a Morter cycle. The motorcycle engine works by burning gasoline. As the liquid gasoline goes into the engine, it evaporates into a gas and ignites, giving off more heat. When a gas is closed in a container and the heat goes up, the faster moving atoms push harder on the sides of the container. This is what we call increase of pressure. When a gas gets hotter, the temperature goes up. In a motorcycle engine, the increased pressure pushes on the pistons, which makes the wheels turn. Hope you enjoyed my LEGO presentation on solids, liquids, and gases. Bye! Thanks for watching! This is Sean Tish, the scientist.